Hello students, today we will see the theoretical explanation for the experiment second order active low pass and high pass filter. Aim of the experiment. So you have to design a second order Butterworth active low pass filter for a given cutoff frequency of 1 kHz and a pass band gain of 1.586. You have to conduct the experiment. You have to plot the graph and find out the frequency response, and also you have to find out the roll-up factor. Now, what is a filter? So as we know, filter is just a frequency selective circuit which allows certain frequency range of signal to pass and it rejects certain signals with different range of frequency. So the unwanted signals, usually they are getting rejected, and the signals which we require, they are going to be selected on a frequency basis. That is one filter. Now, coming to the types of filter, based on components used, basically we have active filter and passive filter. So what is one active filter? A filter which uses certain active components in addition to passive components like resistors, capacitors. That is one active filter. In this case, what filter we are going to design is one active filter. Here the active component used is one op-amp. So op-amp is used in addition to resistors and capacitors. That is why the filter which we are designing is known as one active filter. Coming to one passive filter, the filter which uses only passive components like resistors, capacitors for its construction, that is known as one passive filter. Based on operation, the filter can be analog and digital. So analog filter is one which works on analog signals using analog techniques. Digital filter is one which works on analog signals but using digital techniques. Then based on frequency range of application, it can be audio frequency filter or radio frequency. So as we know, the filters which are used for low frequency in audio frequency range, they are audio frequency filter, and the frequency which we use for higher frequency range, that is radio frequency. Usually, radio frequency filters should have the components which will satisfy or which can withstand with higher frequencies. That is, usually we go for inductors in the filter circuit. Now, based on frequency selectivity, we have many types of filters. So, depending on the range of frequency, it is going to select and it is going to reject. It can be a low pass filter, high pass filter, band pass filter, band reject filter. Coming to a low pass filter, usually the filter selects the low frequency range starting from 0 to a upper cutoff frequency. And after the cutoff frequency, the signal with certain frequency are going to be rejected. When you come for high pass filter, it is one filter which usually rejects the low frequency components till the higher cutoff frequency, till the lower cutoff frequency, and it selects the frequencies which are above that frequency. After that lower cutoff frequency, whatever is the frequency, it is going to select. Band pass filter, it selects a particular band of frequency range and it rejects the other band. So it has a higher cutoff frequency as well as a lower cutoff frequency. Again, this is divided into wide band pass filter and narrow band pass filter depending on its selectivity and quality factor. Similarly, band reject filter, it has again a band reject, so reject frequency within which it is going to reject the signals. Beyond this, it is going to select, so it will also have a higher cutoff frequency and lower cutoff frequency. It is just the reverse of a band pass filter, we can say. Again, it is divided into wide band reject and narrow band reject. Then coming to the last one, all pass filter. It selects all the signal frequency, but then what is the difference between the output and input? So if we'll see, the difference is the output is a phase shifted version of the input. That is the only difference. Okay. So coming to your experiment, low pass filter. You can see the circuit. Now in the circuit, this part of the circuit where you have two resistors and capacitor, this is known as the frequency selective part. And the part of the circuit where you have your RF and R1, it is your gain part. Now the filter we are going to design is one Butterworth second order active filter. So since it is one active filter, you can see you have got one op-amp in addition to the passive component resistors and capacitors. That is why it is active. Why it is one Butterworth filter? Here, we designed the filter according to the Butterworth rule where the pass band is also smooth and the reject band is also smooth. And remember, for a Butterworth filter, the gain is fixed to 1.586. So for this circuit also, the gain is fixed to 1.586. One more thing you can notice, the input is given here, which is given to the non-inverting terminal of op-amp. So we can tell that the op-amp is working in non-inverting mode of operation. So the gain of the op-amp is decided by 1 plus Rf by R1, where Rf is the feedback resistor, R1 is the input resistor here. So 1 plus Rf by R1 is fixed for a Butterworth filter, that is 1.586. So this part of the circuit you have to take care in order to design the gain part, that is equal to 1.586 in the pass band. Coming for the frequency selectivity, as it is a low pass filter, so it has to select the low frequency components and it has to reject the high frequency component. For that, we have the resistor capacitor connection in this way. Now during low frequency, what we want, the signal should be selected to the op-amp. So here, whatever the input we are giving, nothing should be grounded, rather they should follow to the input of the op-amp. Now during low frequency, we know the reactance of the capacitor is very high. So this capacitor reactance is going to be very high. And the signal always try to move through a path where the resistance offered or the impedance offered is less. Now during low frequency, the reactance offered by this capacitor C2 is very high compared to the impedance offered by the op-amp. So the signal, instead of passing through the capacitor, it is going to be selected and it is going to pass to the op-amp. But as the frequency increases, the reactance offered by this capacitor is slowly reducing, and at that time for a high frequency, when we go slowly, as the reactance offered by C2 capacitor is less than the impedance offered by the op-amp, so the signal, instead of going to the op-amp, it will take a path through the capacitor and it will get grounded. Now in that way, the op-amp is going to work. So this is the filter is going to work. So this is the working principle of the filter, where at low frequency it selects the signal and it amplifies it according to the amplifier gain set as 1.586 and we get the output. And as the frequency increases, it is going to reject the signal and the signal gets attenuated and it gets grounded through the capacitor rather than getting selected by the op-amp. Now coming to the next thing, so this is what I discussed is the construction for a low pass filter. So during low pass filter, the connection is like this. During high pass filter, it is going to just reverse. The capacitor is going to come here, the resistor is going to come here. I'll explain you that once again. Now coming to the next part, why it is called a second order low pass filter. So remember, as we increase the order of the filter, the selectivity is going to increase. So what is one order of the filter? How the selectivity is going to increase? If we see the model graph of the filter, so this is our pass band and this is the reject band. But you can see in the reject band, the output doesn't come abruptly to zero, rather it is decreases slowly. Now, what is our aim when we want to reject it? We want that the output should come abruptly to zero in the reject band. So that will happen if we are going to increase the order of the filter. So as we increase the order of the filter, this rejectivity is very good. The rejectivity of the filter in the reject band or in the attenuation band is very good. So that gives us the order of the filter. Now, usually, if we'll see the reject band and we'll calculate the slope for a second order filter, it is minus 40 dB per decade. For a first order filter, it is minus 20. Similarly, for a third order, it is minus 60. It is like this. Okay. So, in order to do that second order filter, we have got here two combinations of RC. We have got two combinations of RC. If we want to make it only first order, then we have to get one combination of RC. Similarly, if you want to make it third order, you have to join one more RC set. Okay. So this is how it is called a second order filter. So the circuit connection is like this. Now let us come for the designing. Now in the exam, you will be given any cutoff frequency. It can be 1 kilohertz, it can be 10 kilohertz, it can be anything. So you have got a very simple equation for this. So initially for our simplicity, we are assuming that R2 equal to R3 equal to R, C1 equal to C2 equal to C, right? Now coming to the equation, what we have, the cutoff frequency of the op-amp is given by 1 by 2 pi RC. Okay, so where R2 equal to R3 equal to R, C1 equal to C2 equal to C. So this R can be calculated here. So see, so what we are doing here, we are assuming the value of capacitor usually less than 1 microfarad. You can take any value, it is dependent on you. According to that, you can find out the value of R. So here we have assumed the capacitor value 0.0047 microfarad. Accordingly, we have got for 1 kilohertz cutoff frequency, the resistance value is 33.86. Similarly, the next part is the designing part of the gain. So as I told you, for a butterworth filter, it is fixed 1.586. So we have got the gain equation for one non-inverting op-amp. 1 plus R8 by R1 is equal to 1.586. So we can choose a ratio. So we get a ratio, the relationship between RF and R1 like this. So we can choose any value of R1, accordingly we can find out R. The load resistance can be kept fixed to 10 kilo ohm. So this is how you are going to design the circuit. After that, coming for the procedure is very simple. As shown in the circuit diagram, you have to do the designing, you have to place the frequency, the resistor and capacitor for frequency selective circuit as well as for your gain part. Then what you have to do, you have to start your experiment from 100 Hertz. So initially give input of 1 volt peak to peak sine wave. Set your signal generator to 100 Hertz and start taking your readings. So what you will see, initially since it is a low pass filter, you have got the pass band. So the output, if you are giving 1 volt input, the output must be 1.586 because in the pass band the gain is fixed to be 1.586. So after 100 Hertz, you go with a step of 100, 200 like this till 900 Hertz, 1K. When you reach towards the cutoff frequency, you will see that slowly the output is reducing. And near the cutoff frequency, it would have reduced a little bit. Then after that, after 1 kilohertz cutoff frequency, when you go beyond, you take the frequency with 1 kilohertz division, that is steps, that is 1 kilohertz, 2 kilohertz like this till 10 kilohertz. Then you will see that the output is decreasing drastically. Now you have to maintain the tabular column like this. So these are some example we have already done, and here with I am attaching also the link for the practical experiment conducted in the lab. This is the theoretical explanation. So you will be getting certain values like this. Now 1 kilohertz to 10 kilohertz, it comes in the reject band. So this is the gain in dB for 1 kilohertz. This is the gain in dB for 10K, right? So after that, you have to find out the roll-off factor. That is nothing but the slope of the reject band in the reject frequencies. So you have to find out the difference between the gain, that I will tell you what is the difference. So the difference between 10 times, that is 10K and 1K. Okay, we are finding out the roll-off factor in terms of dB per decade. Decade means the frequency ratio is 10. So in the reject band, you are going to choose two frequencies which is in the frequency ratio of 10. So preferably we choose one is the cutoff frequency 1K. So 10 times of that goes to 10K. So we have to find out what is the difference between the gain of these two values, these two frequencies. So that is going to give you the roll-off factor. And remember, the roll-off factor is always negative since the slope is decreasing. Okay, so after the experiment, you have to calculate the cutoff frequencies. You have to plot the graph like this in dB. So you know this, you have to come 3 dB down and you have to find out the cutoff frequency. You have to find out the cutoff frequency and also you have to calculate the roll-off factor. So that is the part that you have to do, and practically how much value you are getting, you have to write. Similarly, for high pass filter, you have to design the circuit. The only change you can see here is the capacitor and resistor. That position is changed. They are interchanged. Why? Because in high pass filter, at low frequency, we should reject the signal. So at low frequency, this capacitor gives a high impedance. So very less signal is going to the op-amp. They cannot just cross the capacitor and go. So very low signal goes to the op-amp. But as the frequency increases at high frequency, this impedance becomes less and the signal is selected to the op-amp. Okay, so at low frequency, it rejects the signal. At high frequency, it selects the signal. Now the procedure is same. The calculation, everything is going to be same. You have to start from 100 Hz. But here you will see that starting from 100 Hz, initially the output is going to be very low. And as you reach near the cutoff frequency, the output is going to be constant nearer to 1.586. Okay, so similarly, you have to find out here the roll-on factor. It is called the roll-on factor because the slope is increasing. So here it is written roll-up, it is not roll-up. So it is a roll-on factor which is going to give you a positive value 40 dB per second. Okay, so the related lab experiment, the practical session is linked, is given in another one link which is given together. So you can go through the practical experiment also. So that is all regarding the low pass and high pass filter.